Without further ado, I bring back Dr. Robert Bailey, who is a professor of science at Kawartha University, our vice chair, and a bunch of other things that he's doing. I think he does stuff on the side too, like acting or something on a stage. So anyways, he's going to talk about E. coli in the summer weather in the Kawarthas. Mr. Actor. Bob the tech guy, vice chair.
Thanks, thank you very much. Just gotta put my show up here. One sec. So, E. coli is very personal, I guess, not just for me, for all of us. We've all lived with E. coli all of our lives, but it's especially personal for me because before my wife and I moved to a condo a couple of years ago, but prior to that, we had lived on wells, private wells, for about 25 years. Starting with a hobby farm outside of London from 97 to 2009, a great place in Cape Breton from 2009 to 2015, and then a place, I don't know if anybody's been to Harwood on Rice Lake, place there for six years or so, and of course, my hideaway, my little bit of paradise, our place on Lower Buckhorn Lake in 2012, we got there. And the reason I said it's personal is because it was, we dealt with E. coli spikes, certainly on the farm, a couple of them, but the perfect storm was a few years ago when we had E. coli contamination at both the cottage on Lower Buckhorn and our house on Hillview in Harwood simultaneously. So I know something of the angst that folks feel, and as Ed was talking about the initial motivation for KLSA and the E. coli sampling program from the tragedy of Walkerton. What I want to talk about today is really about, as I mentioned when I was talking about the E. coli program, a bit of a different question for us. And that is, rather than focusing on E. coli in drinking water, which is a significant issue, it's the challenge of E. coli in recreational waters, such as the Kawartha Lakes, our sampling program. It's a less significant issue because we're talking about the safety of swimming in recreational waters and trying to avoid kids and others getting sick, as opposed to the tragedy of Walkerton, that sort of situation. But it's still a very significant issue. If you can't see the article below here, there's the Walkerton case 25 years ago, as Ed pointed out. This was after a big rainstorm in Toronto, 2 summers ago. There was, as often happens in urban water management systems, there's a lot of overflow of stormwater and untreated sewage that went into Lake Ontario that led to the closure of 6 public beaches for an extended period in Lake Ontario. And of course, and Ed mentioned this, I think, in the annual report, the Olympics in Paris last summer, where finally, and this is a recent article down below there, it was a goal of the French government and the government in Paris to make the Seine usable for Olympic swimming competitions. And they achieved that goal, but if you can't see the y-axis, the graph that's above here is the concentration of E. coli in water at various sites in the Seine. And just to kind of calibrate it, so the level at which Ontario public beaches get posted now is 200 colony forming counts per 100 mils of E. coli. And I'll explain that in a sec. The levels that they were seeing in the Seine were This on the y-axis is 1,000, this is 2,000, this is 3,000. So you can see the levels were well above what would be considered safe in Ontario public beaches. So this challenge of E. coli in recreational waters is significant, and it's obviously of significant interest to our community. So I wanted to talk about those 11,000 plus samples we've taken over the last 25 years, including this past summer, and look at the relationship between those samples, the results that we're seeing, and the weather. And that's what I want to talk about today. Before I do that, I want to just say a couple things about the biology of E. coli, just to kind of ground us, because it tends to be E. coli, bad, terrible, bad news. And I completely, as I said, I understand that from personal experience and other challenges we've had publicly, but I just want to point out a couple of things about the biology, and I have to be careful here. Ken Wilson, who introduced himself as a member of Scugog Lake Stewards Board, is also my boss. He's the Dean of Science at Ontario Tech, and so I can't say anything out of line here. Ken will wrap my knuckles later. But so thinking about the biology, E. coli is an incredibly diverse organism. The concept of species is pretty complicated with bacteria. Let me leave it at that. But there's hundreds of varieties of E. coli. And a minority of them are actually responsible for those horrible toxic events that we see periodically. You see, my attempt at humor here is the Sibley Field Guide to E. coli of Eastern North America. That's just making the point that when you get, those of you who sample E. coli, when you get your numbers, that isn't telling us which, is it the toxic form, is it this form, that form? We don't know. We just get, it's like a monitor. It's a way to say, okay, here's how much E. coli of all different varieties in the water. You get an idea of the size of it in this micrograph here. I don't know if you can see this white bar here is 5 microns long, and you see a bunch of E. coli cells in that micrograph. A human hair, just for scale, is 50 to 100 microns in diameter. So E. coli are pretty small. And, but there's a lot of positive things. I'm here to speak, I guess, on behalf of E. coli a little bit. Because there's a lot of positive things E. coli do for animals in general, and particularly for humans. We couldn't live without the E. coli that I keep pointing at my stomach, that are in here. And also, in last, I don't know, Ken, 25 years or so, E. coli have been used because of the miracle of molecular biology and transferring genetic information into E. coli. They've been used sort of like this industrial scale chicken farm you see here. All these poor little chicks are headed for Swiss Chalet eventually. E. coli has been used to produce pharmaceuticals like insulin. So E. coli, the takeaway message is that E. coli gets a bad rap. It's just to be aware there's more to the biology of E. coli and the importance of E. coli than what we talk about when we do talk about the challenges in either drinking water or recreational water. So how do we measure it? Let's get down to brass tacks. So when folks hear, or when I do Laura Buckhorn, thanks to being taught by Mark Potter, when we take that sample and we keep it cold, the reason we're keeping it cold is E. coli, as I mentioned, it does best in this nice, warm, anaerobic, without oxygen environment in our guts. But it can do okay in a cooler environment, but it doesn't reproduce. More or less, it for the most part doesn't reproduce. So we want to keep those samples cold before they get to the lab for analysis, just so we don't we want to know what the E. coli count was in the bottle when we collected the water in the bottle. So we get the sample to SGS, get it in the lab, and what they do is they say, okay, there's a certain number of E. coli. They can't look in a microscope and see the E. coli and count them. So what they do is they take a sample of that water, they put it on a plate, looks a bit like this, and the plate has E. coli food on it. And they put it in an incubator at basically the same temperature as my gut. Nice warm temperature, and they leave it for 18, 24 hours. And then during that time, every E. coli sample that was on that plate grows a colony. So those little lumps that you see there are a whole bunch of E. coli cells that have grown because those colonies have grown because a single cell was there at the beginning that started eating that food, living in that wonderful warm environment, and reproducing. So that's why the count that you get is how many E. coli colony-forming units there were per 100 mils of water. Okay. So the program, as I mentioned, more than 11,000 samples from 21 lakes over 25 years, and new lakes that aren't in this map this year. Yeah, so this map, not necessary for you folks, but what I wanted to point out is, as I said, I want to look at the relationship between the weather and E. coli in our recreational waters. So I got data from Environment Canada, Environment and Climate Change Canada, at least for now, from 2 weather stations. This is Trent University's weather station, this is the Peterborough Airport. So you can get weather data, daily weather data from those stations back, I think, to 1968. But anyway, we looked at the weather at those stations over that whole period that KLSA has been sampling E. coli. So what I do when I kind of take on a project or a study like this is I kind of think of it, and then, you know, from a sort of scientist point of view, is when I stick that bottle in the water and get my sample, what's affecting how many E. coli cells are in that bottle? That's what I want to figure out here. So what you're looking at is to put it glamorously, I guess, my conceptual model of what determines E. coli that I get when I take a sample. The factors that are stippled are ones that I can't really model. And I'll explain at least a couple of them in a sec. The factors that I can model in the open boxes, like the weather in the year of sampling, which we'll see some stuff about, the year of sampling, because things can happen in the year of sampling other than the weather that can affect what the E. coli is. And the weather on the day of sampling and in the prior 2 weeks, that we can look at. But these other factors, I can't really model, and for a couple of special reasons because of the nature of our sampling program. So one of the things that I think everybody knows affects how much E. coli is in the water is the nature of the site. Where's the site? You know, I've got one off the end of my dock in Blackduck Bay. Mike's site, I forget where is it right near the...
Just right from my beach.
Right off your beach. And as those of you who participated in the program know, I don't know, except for the sites that I sample, I don't know exactly where people sample, and we certainly don't publicize that. So there's confidentiality around the sampling, because our E. coli program is really about folks wanting to know what's happening to E. coli at their site. And so I can't model, you know, the parameters of the site and how that might be affecting the E. coli concentration. That's out of my control. We are doing that for Toronto public beaches, which, spoiler alert, they're horrendous compared to our sites. But so I can't model the aspects, the nature of the site. I can't even model, don't worry, I'm not going to say this lake is better, quote unquote, than this other lake, because the way that sites are chosen in our program is, Patty and her group are willing to pay for 6 or 8 sites you do? Yeah, so, but we're not all, including me in Lower Buckhorn, we didn't set out and say, okay, how do we characterize E. coli in Lower Buckhorn Lake? It's very much site-specific. Steve's sampling at his place, Mike's at his place, and that's so. I don't want to draw any conclusions from how E. coli might differ between Lower Buckhorn and Cachoenuca, because the study hasn't been designed that way. I hope that makes sense. We can talk about it later if you want to ask about it. But like I said, what I can do, is look at those 11,000 plus samples and see, okay, what's the effect of weather in the year and weather just prior to sampling? Because those of us who've done this for a while suspect there's something going on there, which there is. Okay, here's a slide. I'm probably going to use this for the next 10 years, whatever amount of time I'm running the E. coli program. This is, and I just want to train you on a box plot if you haven't seen one before. This is a distribution of all 11,000 plus E. coli samples that we've taken over the 25 years. So just to orient you with this box plot, the bottom of the box, there's 25% of the observations are that value or less. And the bottom of the box, if you can't see the y-axis clearly, is 0. So more than 25% of the E. coli samples across those 25 years were 0. Had no E. coli, or at least no E. coli detected in them. The median, the average amount, so that's 50% or higher than that, 50% less, was about 2 colony-forming units per 100 mils. And the top of the box means 25% of the values are higher than that, and the top of the box is less than 10 colony-forming units per 100 mils. And then you see the spike coming up, which is like the range, more or less the range, that spike coming up to over 100, and then a bunch of dots which are outliers, they're extreme values. So, and that might seem like a lot, but keep in mind those dots, and I think there's about 20 or 25 of them, out of 11,000 samples. So here's my first take-home message. In terms of E. coli, our water's looking pretty good. Okay? Just wanted to point out, I don't mean to out Pigeon Lake or anything, but that big value at the top was from 2002. I had no idea that was well before my time, so I can't take credit or blame for it. They had a value of 15,000 in August of 2002. Maybe somebody from Pigeon Lake can get to that later. Okay, so just to kind of summarize what I just said, because this gets into how I'm modeling. Here's a basic bar chart. The big black bar is the proportion of E. coli samples across the board, across the 25 years, that was above 0, that actually had an E. coli positive sample. So about 73% of samples. And here's the proportion, which is going to become important to us. Remember, the median was like 2, and 25% were bigger than out of 8 or 9 or 10. So here's the proportion of all those samples that were greater than 10 colony-forming units per 100 mils. So it looks like it's about 23% across the board. And finally, we get concerned, those of you samplers among us, I think I contact you if if it counts over 75 or 50 or something like. We have a conversation, an email conversation about it, maybe think about a retest, think about reasons. So here's, for those of you who have, like me, have had a spike over 100 off the end of my dock, here's the proportion of samples across those 11,000 that were over 100 colony forming counts per 100 bills. So it's around 1.5, 2%. And by the way, again, spoiler alert, that was true this year as well. There was, out of the 275 or so, or 300 samples, there was a few spiked above 100. Okay, so let's talk about weather for a sec. And I gotta orient you on this graph, because this is, again, for my beans purposes, this is a brilliant way that I thought of characterizing the weather over the 25 years that we've done E. coli sampling. So first of all, to get you oriented, I'm only talking about the summer here. So what I did, I downloaded all that weather data, and I characterized the weather each week through the summer for all those 25 years. So each of those dots you see is a week in the summer sometime, okay? And two descriptors that you're looking at is this weird thing which my wife said no one would understand. I think it'll be obvious. I thought it was brilliant, but anyway, the weekly average maximum temperature. And it's just like, for last week, the high tomorrow is going to be 22, the low is 18. The high value, I just averaged those up across the week in the summer. So you can see that across all of our 25 years, there was a week in September 2014 that was well below, average well below 20 degrees maximum temperature. That's not unusual. It's probably less than 20 this week. And there was a week in July of 2020 that the average max over a week was well over 30 degrees. Again, heat wave. So in terms of rainfall, and you see the same kind of box plot there for temperature across the top. So the median, weekly max, the range of them, a couple of extreme values on the low end. In terms of precipitation or rain, you see the range in that weekly. This is just the total amount of rain in a week. And it varies from nothing, kind of like several weeks this past summer, to July 2004 when I wasn't here. I don't know if anybody remembers the incredible rain week in July 2004, but so quite a big range in rainfall. And this is just giving you an idea. This is the kind of descriptor that we can use to relate what we got in terms of E. coli concentration relative to the weather. Okay, so here's, I don't know, this is slightly, I was going to say convoluted, but I'll say, again, just kind of here, sophisticated way of, I kind of took all the weather data I had, and I wanted to summarize each year of the, and all this, I agree. So there's lots of stuff that is folded into the explanation of year in terms of what we see in E. coli that I haven't modeled. This was the first step to say, okay, year seems to be important. Maybe the weather in the year is a big part of that. It seems to be at least part of that. I don't know if I'd say big, but that was kind of fun to find out. And just to, again, remind you of the extremes there, 204 with the 23C high and 20 millimeters a week of rain. 2016, which I didn't talk about before, had 28C high and 10 millimeters a week of rain. So a couple of points to finish up with. Hopefully we have a couple of minutes for questions or comments. First of all, E. coli in the Kawartha Lakes low. Okay, no question about it. And I'm not, I should hasten to add, I'm not in any way minimizing the importance of when we see a spike and there seems to be a cause related to human activity of some kind. That's the foundation of our program, actually, as I talked about at the beginning, is people wanting to keep an eye on particular sites in their lakes, right? So I'm not minimizing that at all. I'm just saying, as a region, our Kawartha Lakes, E. coli is low. Imagine the difference in my take-home message when I talk about Toronto beaches to a group in a couple of years, because I got 2 students working on that Toronto beach data, where the median for, has anybody here been to Sunnyside Beach in Toronto? Never go there again. I've seen the data. But yeah, our Kawartha Lakes, E. coli, as you saw from that box plot, low. Pre-sampling weather modestly affects the chance of an above average E. coli sample. So the nature of the weather at 2 weeks leading up. In any given year, the summer weather affects the chance of an above average E. coli concentration, right? And I would say more than modest, given the relationship that I saw there, but there is evidence that the summer weather does affect your chance of seeing an E. coli concentration more than 10. But the final take home is the rare spikes that we see, because again, we saw a few spikes this year, and the volunteer force, E. coli volunteer force, they know this. We've had conversations about it. They've been doing it in many cases longer than I have. So the rare spikes that we see in E. coli concentration are most likely due to site-specific abundance of waterfowl and other local factors, where the site happens to be in relation to waterfowl, combined with vegetation, combined with inflows, and also, in some cases, combined with human activity. I want to finish by thanking that E. coli volunteer force, and because I know the main reason for getting the data, as I said, and the main reason Mark and I have done at Lower Buckhorn, is to keep tabs on our sites, but you've contributed to what I think is important science here, and I acknowledge your work in that. So thanks very much, and I think we have time if anybody's got any questions or comments.
So the reports that you get from SDS have 2 numbers, coliform and E. coli. Is E. coli the most important one, or are the 2 important?
E. coli is the most important. The question was, SGS report gives coliform and E. coli. And as I was saying, so E. coli is a subset of coliform. And remember, as I said here at the beginning, the dangerous E. coli are a small subset of E. coli. So the best measure to look at, and the one that I've looked at here, is the abundance of E. coli.
So do we pay attention to coliform at all?
I would say no. Yep.
Is there anywhere in the Kawarthas where sewage is untreated?
Is there anywhere in the Kawarthas where sewage is untreated?
Like most places are regulated and actually there are samples taken and usually the things are pretty good. I just wonder if there's anywhere left where it isn't treated when it gets dumped. I asked that because many years ago, I was a clearance diver in the Navy, and Esquimalt, Halifax, and particularly Panama was a bloody disaster.
Yeah. Okay, so the answer is no in the context of your question. When I lived in Cape Breton, one of the projects I worked on actually, because Halifax is quite recent that they've done somewhat of a job, but in situations like that, same thing exists on the West Coast. It's kind of like solution to pollution is dilution, so that they are dumping They have dumped raw waste in the water, but no, we have, as Mike has reported really well over the last many years on our sewage treatment plants. The reason I pause is I'm trying to think, well, I'm sure there's cases with individual residences where there's a problem, and like I said, if you go back to our annual reports, there's been several times where the individual sampling has revealed a challenge with human activity leading to spikes. But yeah, our sewage treatment plants generally operate quite well. They have the same, different kind of challenge, and I would say not as significant. I don't know what Mike thinks about this in terms of the effect of storm events. Toronto can be a mess because Toronto is essentially a paved watershed, right? So whatever happens in terms of rainfall, and that rainfall event in July of 2004 was when there's a meter of water in underpasses on the Don Valley. So all that water overcomes any kind of storm or sewage treatment. That's why you get those overflows in usually our large urban areas. We kind of get a modest version of that in some storm events, I think, Mike, where there can be overfall, but it's extremely rare, and generally speaking, the water that's sort of coming out the pipe is in good shape. Yeah, Mike, do you want to add to that?
I'd just like to say, a number of years ago, Mike Stedman, Kevin Walters, and I met with the Ministry of Environment down in Vancouver, who were responsible for licensing and sewage treatment plants, not just the municipal ones, but also ones we don't think about. For example, trailer parks. There's a trailer park quite close to us on Catchmanuka, and we'd observed that it had been sold a few years before we met with them, and there were, we knew that there had been activity, that they were building a new treatment plant, essentially septic system for the trailer park, and there was concern by some of the neighbors. And I happened to ask about that, and they said, oh yeah, they have to be, they had to submit their plans, they have to have an approved plan for operating that. And so there's a lot more going on that we actually hear about or think about. I only report on municipalities like Kawartha Lakes, who operate treatment plants in Cajun, Fenelon Falls, etc. But in fact, there are small developments that are required, if they put in rather than if they have don't have individual septic tanks, if they put in a collection system to treat it collectively, they have to submit their plans and have approval from Ministry of Environment, and every year they have to submit a report. Ones that I normally analyze for the municipalities, those same other systems every year are supposed to submit a report to Ministry of Environment. They wouldn't tell me anything about the one for the trailer park near me because it's considered private information. But they are there. So there's a lot more going on that we actually hear about.
Mark?
I'm just curious, back in the 60s and 70s, Persian Lakes, Geogog, I think, Stony, we were getting green water in the summer frequently as part of the Lindsay plant. They cleaned that up. But the relationship between E. coli and phosphorus and these algae blooms, the blue-green algae, are we anticipating more of those, or is that under control? The lakes won't turn green anymore. I'm curious.
Well, first of all, I would say that relationship between E. coli and phosphorus is tenuous, especially given reasonably good sewage treatment. I mean, phosphorus as a challenge, and I think we have tertiary treatment at all of our sewage treatment plants now, which means translation is they have mechanisms to reduce the amount of nutrients, phosphorus being one of the prime ones. So E. coli arm in arm with E. coli as a cause, I guess I would say, as a cause of algal blooms, no. In the present environment, are there going to be more blooms? See, our lakes, I don't want to get into, and Ed won't let me, to sort of a general limnology lecture, but our lakes, the nature of our lakes, especially with interacting with Brett's work, you know, on the change in the temperature and oxygen regime of the lakes. So more of the phosphorus that's there is getting renewed up in the water column. That's helping those algae and the pesky weeds. Anybody else have like the worst weed year in a long time this past summer? Yeah. That's another talk, but yeah. So I think Mark, my concern about phosphorus would be as much about what's happening in terms of the changing physical environment of the lake as anything to do with input from sewage treatment plants. If that's fair to say. One more. I don't know who was first. Okay, I guess you were.
I think I can explain your outlier in Pigeon Lake in 2004. So at the time, she'll correct anything, but we were battling a developer on Boyd Island site, and we were having meetings with the municipality of Boston concerning the potential addition and in general situations there. And I think they had an event at the relatively new sewage treatment plant at that time. I think we had to let it go.
Okay.
All right.
Yeah, there's
obviously what hasn't been one since, so.
well, and there's another, again, rationale for, Ed and I were talking about a few months ago, you know, given the water's so good, should we continue the E. coli program? And I think there's justification for it, not just because it can help good science happen, but in the very first report, I think it was, Mike, where the Lakefield School issue, where and nothing against Lake, they actually operated, I think, very constructively in the response. But that, you know, we act as kind of a monitor. The folks that do choose to do sites or association to do sites can help identify individual situations and figure out if, is this a longer, more substantive problem that we can do something about? Is it those friggin' geese or whatever is happening? So, yeah, thanks for that. Okay, I'll get out of here. Yeah.
Thank you very much, Bob. And I know there's thank you, really, really good information. And I know there's more questions, but we just can't keep going. We have other things to do. So when Bob and I were talking about who should we invite and what kind of presentation speakers should we have here, he spoke up and he said, you know, I think based on our discussion we had which he mentioned about should we keep on with the E. coli program, maybe I'll do a presentation on the 25 years of E. coli. And then he said, and I want one of those big gift baskets that the guest speakers get. I think he deserves it. There's some really, really hard work put into what he presented here today. So there you go, Bob. Thank you. Yeah, so we had comments, and there'll be a break, and afterwards you can talk to Bob, and if hopefully we can get the other stuff done here. Good job. I wanted to mention that we have two exhibitors here. Kawartha Conservation, Carolyn Snyder is here at the table at the back here, and I'll have her up here for a quick talk about what she's here about. And we have invited our native plant suppliers to come here today. Pinewood Needles could not come, but they did send us a dozen plants here, and they are our door prizes. That's how you all got tickets on your way in. If you didn't, run back and Jess will get them to you. We're going to have a draw in a minute, and then towards the end of our meeting. So there's 12. Rockwood Nurseries, another biggest supplier, they're outside the door here. They've brought 150 potted plants, shrubs, whatever, and they're available for sale at a good price. So during the break, go out there. There's a couple of fellows there. They brought a machine with them so they can take your debit credit information as well. So, and I would really appreciate it if you supported them. They continue to supply our plants, and I've got to go see them, I think, in a couple of weeks to get a bunch for Kim's Plantings. So I'm going to invite Carolyn up right now just to say a few words on the Kawartha conservation material and programs to what she has, and then go visit her at the back, okay?
Thank you, Ed. I think I've talked to most of you now, but I welcome you to come back again and chat with me. As Ed said, my name is Carolyn Snyder. I am the Community Engagement Technician with Kawartha Conservation. I'm just going to go over 5 of our programs that we have that are geared to helping landowners and community groups. So the first big one that we have is our Kawartha Water Fund. Now that does only happen within the Kawartha region. I have a brochure at the back that highlights that area so you can see if you're in that. But it's going to be opening again early next year. This program helps landowners and community groups within the Kawartha Lakes who want to complete environmental projects on their properties. So this program for the landowner side of that, that's 50% of project costs up to a maximum of $4,000. A little different for our community groups. You can potentially have 100% funding depending on how the external committee votes. We also are going to be continuing our partnership with Forest Canada's tree planting program. So this provides subsidies to landowners for large-scale tree plantings on their properties. It's a really great program to help improve biodiversity and increase forest cover as we all probably struggled through the storm this year. This is going to be an incredible program for those that are looking to reforest some of what they've lost. Along with that, we also offer an annual seedling sale. So that will open probably late November this year. They're usually bundles of 25 seedlings, bare root, and they're again at a reduced cost for landowners to be able to reforest and plant more native species on their land. We also have, new to us this year, is the ALICE Kawartha Peterborough Northumberland program. ALICE is Alternative Land Use Services. So that is geared towards farmers that are looking to implement environmental projects on their farms. So that's anything from buffer strips to creating pollinator habitat or restoring wetlands. ALICE supports farmers in making those practical decisions. I have some information with that again at the back. And then additionally, we also have our community science program, which is made possible through people like KLSA who support us and volunteers, and that is monitoring our lake health with volunteers. This year's findings will hopefully be out shortly, and that is for balsam, Cameron, sturgeon, and pigeon lake. And I believe again next year we'll be looking for more volunteers. And that's basically all I have. There are other programs that we offer, and I'm more than happy to answer questions at the back. Thank you.
Thanks, Carol. Go visit her at the back if you haven't already. Okay, it's that time. Jess, can you bring up the draw bag, please, with the tickets in there? Everybody get your tickets out. We're going to draw 6 now, and then have a break where you can go and purchase plants and go see Carolyn and talk to each other and us. Kim's going to help identify the plants that you can choose as your draw comes up. And yeah, we'll get Jim, could you hit these lights here so that people can see the plants? Okay. Carolyn, come on up and pick a couple of tickets out for us. Come on up when you're winning. Come on down. Down, up, this way. And get to choose your first choice.
5901952.
The winner. Get you first. Yeah, we'll fire it. Yeah.
590-1950. Five nine zero 1970. Five nine zero 1949.
No winner, check. Somebody win it? That one is signed.
Yeah. 590-1948.
There we go. We'll keep that one aside here. That's it for now. Thank you very much, Carolyn. And I will say, nobody's picked the raspberry. These plants have been sitting in my yard all week because I picked them up, and those raspberries are good. I had a few. So, okay, I believe it's break time. So once again, well, what time is it, first of all? Make it 11:35. 11:35, we'll call you back in here. We've got Leslie Lavender from FOCA to speak to you, and we have a special announcement. So in the meantime, go on out, buy some plants, put some in your properties, and go talk to Carolyn. Thank you.
In school, we used to have BOD 5. It's old technology, obviously. Because I remember when I started